If you build an easy-to-use portal to the world of quantum coding, eventually, companies are going to take notice and want to offer the environment to their teams. Learn how you can interact with quantum computing hardware and software of all types, either on your own or with your teammates, in this episode of the Post-Quantum World. I'm your host, Konstantinos Karagiannis. I lead quantum computing services at Protiviti, where we're helping companies prepare for the benefits and threats of this exploding field. I hope you'll join each episode as we explore the technology and business impacts of this post-quantum era. Our guest today is the CEO of qBraid and a repeat guest, Kanav Setia. Welcome back to the show.
Thank you, Konstantinos. Pleasure being back.
Yeah, lots happened since you were on over 40 episodes ago. It's been quite a while. As we'll get to, I do end up seeing you, though, so that'll come up a few times. But for those who didn't hear that episode, and it was a good one, let's give a little intro to what qBraid is for listeners.
Absolutely. So qBraid is a one-stop platform where you can access all the different quantum software and hardware from many different companies around the world. So you want to access Qiskit, Cirq, AWS Brockhead, Rigetti's Pikequill, Xanadu's PennyLane, you name it, we have that software available. Currently, we also support more than 5 different quantum computers available on our lab platform. So essentially, you just come in, everything's pre-set up, you open a notebook and start running the code, start submitting the quantum circuits, and that's basically what we do.
Yeah, people should be familiar with this kind of concept. If you've ever done a tutorial using notebooks, you could jump in and actually do things in code. It's not that dissimilar from like Google's Colab or something like that. Like you could just go right in there and do something inside of a window. So I'd love to dig into some reasons for why you're back on. So for starters, this isn't a tool for just practicing coding. Although it's great at that. Real businesses are relying on this, right? So I was hoping you can give our listeners a sense of some examples of how real businesses are launching products on this platform.
Absolutely. So as you mentioned, qBraid is similar to Google Colab, as in it has a very similar feel to Jupyter Lab and Jupyter Hub platform. In fact, we leverage the Jupyter infrastructure and build upon it. And make it super friendly for quantum specific tasks. So we build custom extensions that fit right into Jupyter Lab platform that provides you access to Python Environment Manager. So we built our custom UI for Python Environment Manager that allows you to segment your software into various different Python environments. And we have many custom Python environments that we ship by default. So people can just open a Python environment that is custom built for AWS services, and they will get all the software from AWS. Similarly with IBM and Google, Microsoft, Intel, and you name it. And so now people are starting to build their software on qBraid, and sometimes also launch it to their potential customers, do the demos, and so on. We've been working with many quantum companies to launch their custom Python environment so that their tools will be readily accessible to qBraid users and their end customers as well. So what we do is we work with these companies and build a custom Python environment with their software at the art. And so any user can just log into qBraid, install that Python environment, and get access to all the quantum software from a particular company, and just open their notebooks and can readily execute the circuits. Further, within these Python environments, we make sure that these are configured to connect to various different quantum hardware. So there's no separate making accounts required for AWS or many other companies. So you simply come to qBraid, and if you have qBraid credits, so we have our own credit system where you spend money to buy these credits. once you buy these credits, you can turn on quantum jobs, which is basically one line of code or one button in our UI. So you press that button and suddenly all the code that submits job to quantum computers starts executing and your job management happens automatically. So essentially, as an end user, if I want to get access to a particular quantum company's software, I can just get their Python environment, turn the quantum jobs, and I will be set. I will just open their notebooks, tutorial notebooks, and just execute it. And all this, because all the software is present, all the code will be executed. And if there's any jobs to be submitted, they will go through to the quantum computer where I want to send those jobs, and I'll be able to get my results back.
So listeners could visualize what that looks like. You have the credit system, which I notice is different from last time, definitely. And that makes it simple because, like you said, you don't have to have API keys set up for running different jobs and paying like that. So let's say you buy a bunch of credits and you pick one of these pre-selected notebooks from a customer. Would that be something that they're charging you a split, like some of the credits go towards running the machine and some of the credits go towards them as like you're running our software kind of thing? Is it like a whole like ecosystem and economy like that?
We are starting to explore that, but the field is still early, where our focus is mostly on learning and building the right thing. So right now, as you may already know, many of the listeners might already know, quantum computers are not where they need to be to offer real value to the end customer, right? So there isn't any software in the world that you can build that can run on these quantum computers and provide you meaningful advantage over classical software and hardware. So there's not really a whole lot of value in building an infrastructure that allows anyone to build an application and launch it for their customers, that their customers can launch it for the API. So most companies are just open sourcing their software and trying to build community around those. So
yeah, I wanted to make it clear with the credits and everything where those go. Ultimately, they're going to running these not fault tolerant quantum computers. In the background.
So mostly. There isn't any split or revenue sharing with quantum companies, but this is something that is being actively discussed with various of our partners. As in the future, as the business grows, yes, that's certainly something we would do, where if a lot of people are using a particular quantum software from a given quantum company, we will provide revenue sharing with them. So that's a model we have started to think about.
Great. So for those who want to implement qBraid in their organization, I'd love to talk about some of the features. I think some of them are even new from last time when you were on, that help companies do that internally for like managing jobs and functionality and things. So if you just want to talk a little bit about what that looks like if you have a team and you want to implement this internally.
Absolutely. So we recently shipped another awesome feature, which is basically gives organization an ability to make an organization page on qBraid. So what allows them to do is you build an organization, you can buy credits in bulk. So let's say you spend $25,000 and you have a whole lot of credits. So you can have users come in and join your organization. You can give them roles based on different permissions. So all of them will have different permissions, and then you can transfer credits as they go. So what this allows them to do is automatically this problem of overspending it gets sorted out, because you can transfer credits $10 at a time or even $1 at a time. So if the job requires more credits, then it won't go through unless you top it up.
Yeah, that's a great idea.
So that problem is resolved. So any organization, they make their page, give their developers access to quantum computers. Further, where we're starting to build features where they'll be able to even manage the classical compute for their developers. So let's say you are running some huge tasks and you want to simulate them before running on computer. So what we are in the process of doing is giving people access to a scalable compute. We already provide 3-4 different options, as in you can launch a 4 virtual CPU machine, 10 virtual CPU machine, another GPU machine. But we're planning to grow this to maybe 20 or 50 different options where you'll be able to have access to NVIDIA's A100 or V100. And as you go, you can just start up any of these machines, run simulations, test your results, turn off those machines, and you will be billed through qBraid credit. So a single credit system for all your QPU needs, CPU and GPU needs.
And what about privacy and security in that instance? So I'm assuming if an organization creates one of these, they definitely don't want to be sharing it. they don't want this in some community setting. So how do you kind of like guarantee that?
That's a great question. So we generally follow very good practices for all our data. We make sure that it's segmented from any other user's data. Beyond that, if there's a requirement from an enterprise that they further want their data to be encrypted, that's certainly something that we can work with organizations and provide them this service. But it's general security practices that your data is segmented, sandboxed, and doesn't interact with any other common data.
Okay, yeah, definitely. When you get into the realm of developing IP,
yeah,
these things start to come up.
Definitely, this is going to be one of the most important things as the field develops. The issue around IP. Another important thing is as the scale of usage in an enterprise, in an organization grows, we're also happy deploying our software infrastructure to their private cloud. So that way the data never leaves their private cloud. What we would do is basically manage the software infrastructure for them.
That's terrific. Yeah.
We've actually done that with a couple of organizations where we white labeled our product and developed and deployed it on actually just AWS because they didn't have a private cloud. But essentially, the mechanism is very simple. We white label a product and deploy it on your AWS clusters or your private cloud clusters.
That's really helpful. So with these private companies doing that, do they then get a different level of like support to like if they have problems executing something or errors and they need technical help?
Absolutely. So based on the contract size, we definitely bundle in some technical support as well for a certain number of hours. And so it actually just depends on from contract to contract, as in what are their requirements, how much support they're going to need. So yes, we certainly provide that service as well.
Yeah, that's great because when you were last on, this sounded like a great way to learn and explore, and now it sounds like a real tool ready to hit the road, and like actually put some quantum miles on. So it's nice to see that it's growing. And it looks like you're having an impact in academia too. I don't know if you want to talk about qSteam a little bit.
Absolutely. So qSteam actually is one of our biggest customers, and they are the ones who white labeled our product and have deployed it for their own organizations. They're planning on being at 300 universities in the next 5 years. What they're going after is this need of developing content for training future quantum physicists and scientists. So they have an incredible team of 50 to 70 professors at more than 25 different universities, and they're churning out content. And so what we are solving for them is essentially you have this content. How do you deploy this content in a scalable fashion? So we make sure that they have the right tools. So we're building some custom applications for them that will allow professors to build courses within qBraid Lab and deploy it for their users. So they can just publish the courses and then they can add students to certain courses, and all those contents appear in students' qBraid account, that they can just open it and then start running their code, start doing exercises and so on.
So does this look similar to what the blogs look like, where it's just like a mixture of instruction and code?
Absolutely, yeah. So it's basically, you can build notebooks in qBraid Lab and bundle 10 of them, and you can deploy it on the blogs section. And so just imagine bundling up 10 different blogs together, and now you have a course.
Yeah.
And you just have an outline, and then it's the same platform, but now you can just bundle up blogs and you can deploy it as a course.
That's terrific. And then they have a place to put their actual coursework into an interactive mode.
Exactly.
Teachers can see, is their code running, all that kind of stuff.
Yeah.
And they're building. So they're taking the white label that you gave, and are they building any new functionality in the back end, like some kind of like teacher dashboard with scoring and things like that? Or
no, essentially the technology part is what we are taking care of.
Mm-hmm.
It's essentially making sure that if they have any custom needs, because the two products might diverge a little bit, because the needs of the industry might be different than what is required in academia, which is why we thought this might be the best strategy, right? And so then while they are selling the content, they can also sell it along with qBraid Access. And
great.
That was the whole point of like having a white label solution, where now they can also have, we need a course builder, so we can deploy that. But there's perhaps not a huge need of course builder for having it for everyone on the platform.
Mm-hmm. And now you can take this, bragging point, I guess, and bring it back to even companies. And you could say, look, they're using this now to teach in schools. You can use it to teach your employees.
Yeah.
Ultimately, in some way. That's great.
One more cool point is we can also use content and deploy it in the industries as well, because now this content has been validated. And many companies, as you may know, they're just starting out. Their first step looks like, hey, we hear so much about this quantum field. We want to know what it is all about. Can you maybe teach our engineers? And so we can literally take similar courses and use it for training. And of course, need QSTEAM's permission.
It's all one place. Yeah. I was just going to say I'm sure they're doing some of the IP there, but this is all one place, and it works for everyone. One thing to keep in mind is that this is such a challenging field, right, for people to learn. So it's great to see something all bundled up and easy. And the other thing I think we talked about last time is developing these environments for use. It's no small feat, right? It's the reason people first started using containers, because it was a nightmare to like get just the right version of each thing, pip install, and then good luck, like what kind of nightmare comes after pip install.
Yeah.
It's really impressive. That's why I wanted to have you back on and see how this has evolved for business use too.
Thank you. I appreciate that.
Yeah. So we've been spending a lot of time together lately, meeting for the U.S. National Science Foundation competition. So for those who don't know, this is all public information, but the University of Chicago, our Quantum Crossroads team was announced as one of the 16 finalists in this first ever regional innovation competition. So they span all different types of technologies and things, and we're one of the finalists as quantum for things highlighted in the CHIPS and Science Act. So what does being part of a big multi-year competition and possibly winning something like this mean for a company like yours?
It definitely, first thing, brings us so much credibility. It's just like such an amazing privilege to be part of an incredible team led by CQE and U Chicago. It shows that we must be doing something right, that we're getting attention from such amazing folks. So that's one big point. The second thing is we get to be part of an incredible team that's taking up one of the biggest challenges in the field. Not just one. They're going in so many different directions. They've got 3 cores. there's R&D, innovation, and then workforce. All of these are going to be some of the biggest challenges that would need to be overcome to make quantum dream a reality. And to be able to work on these really amazing problems and being part of the solution and struggle with those and make things happen, I think that would be the most fun thing. If the grant comes through, we're really looking forward to contributing towards workforce development, which is what qBraid's leading, and contributing other places as well.
Yeah, I'm involved in more of the R&D track,
Yes.
but we are all like one big team anyway.
Yes.
And what impresses me is that whatever we accomplish, assuming we win this, whatever we accomplish in the Chicago area, I think it would be a great model for what can be done all around the world, to make sure that quantum isn't really limited to just certain folks in certain areas, all sorts of issues like equity and things. I think it's an exciting project to be part of. On that kind of note, I think recently you won some other grants, right? If you want to talk a little bit about those.
Absolutely. So we recently got awarded two main grants. One, Q4Bio from Welcome Leap organization. And that's a grant focused on the use of quantum computers for biological problems. It's up to $4 million, structured in 3 different phases. The first phase is up to 1.5 million. Second phase is up to 750, and third phase is up to $2 million. So we submitted a proposal where we were leading the team, and we have Professor Laura Gagliardi from UChicago, Professor Troy Van Voorhis from MIT, research scientist Yuri Alexei from Argonne, and then we have Professor Ray Samuel from NCNT. So we've got a really solid team, and I think the project idea is also quite fascinating. We came together as a research team and discussed all the different smaller pieces we had in our individual results. It was like really amazing to see how they just fit in nicely together. So you have these bigger protein molecules, and what we proposed was simulating an entire protein molecule, even on biggest quantum computers, even in 30 years might not be feasible because the protein molecules are just so big. And so you can maybe segment these using crude fragmentation techniques, which are available in classical world as well. So what you do is you have a bigger protein molecule, you use crude techniques to chop them up, and you end up with these smaller segments. Turns out these smaller segments still may be big for near-term quantum computers. They might be doable on future quantum computers, but for near-term, they still might be big. And that's where we have techniques from UChicago, Professor Gagliardi's group, and Van Voorhis's group, where they have further segmentation techniques which are quantum in nature. So you take these smaller segments, fragment them further, and then simulate them on quantum computers. And so the smaller fragment is a fermionic system. And the normal techniques you use to map a fermionic system to qubits is something called Jordan-Wigner. So during my PhD, I worked on an encoding called super fast encoding, which when you use that encoding, you have to use more number of qubits, but that provides you more efficiency. So you end up requiring lower gate counts and lower circuit depth. But on top of that, you end up getting free error correction capabilities. So,
I'd like to double click on that.
So we ended up fitting the entire pipeline together, and we would propose that. The reviewers must have liked it, which is why we ended up getting the grant.
That's pretty impressive. Yeah, I was hoping you'd talk about the use case. That's really cool. Protein comes up all the time. If you hear quantum and bio, it's always going to be protein. One of these days, there's going to be a quantum protein bar that we're all going to be eating because it just keeps coming up all the time.
The particular use case we're going after is actually these proteins which end up in markers for Alzheimer's and Parkinson's disease. So there are these proteins called beta amyloid and alpha synuclein. Beta amyloid for Alzheimer's, alpha synuclein for Parkinson's, which apparently react with metals and form these plaques, which are known to be markers for Alzheimer's and Parkinson's. And the way this interaction happens and the way they get formed, it's still relatively understudied and not very well understood. And so this is what we're going after.
Yeah, that's good. I realized it wasn't protein you eat. I just never miss an opportunity for a joke when you can take it, And as far as the error correction, did you want to say something about that? Because that's a pretty interesting approach. The more qubits.
So the error correction, the way it works is the original idea was that, hey, if you have a fermionic system and you're using Jordan-Wigner, you have this order n overhead. And if you were to use more number of qubits, then you can map qubits in certain ways that it ends up causing only order constant overhead. So you reduce order n to order constant, but you are using more number of qubits. And so that's essentially the idea from my PhD, that I observed this, that you were using more qubits. So if you're using more qubits than the number of fermionic modes, so essentially you're using a subspace. And apparently, even the formalism for using this subspace out of the entire Hilbert space was very similar to the stabilizer formalism that is used in error correction. So it was like a big conjecture that I had. Maybe if you're using the same stabilizer formalism, you can just use the same formalism to do error correction as well. So I ended up proving that. Then I worked with Sergey Bravi, whose original idea was like this encoding where they brought down the cost. So we ended up working together and we proposed a new encoding where we showed that in the new encoding, like if certain conditions are met, then you can always guarantee single qubit error correction.
See, there's no such thing as wasted effort in this case. Everything makes a return appearance.
Yeah.
And then I guess you have something going on with NSF Expand QISC?
Yeah, that's another grant that we received in collaboration with North Carolina Agricultural and Technical State University. So we run a different, like a decent number of programs with them. So we've had 2 courses with their undergrad students. We ran a workshop for their training workshop in quantum computing for their faculty. And so we've had like wonderful experience. So we ran the workshop, we trained the faculty, and once they were trained, we ended up applying for a quantum grant together with the faculty. And that's the Expand QISC grant from NSF, which is for $1 million per year for 5 years. And that grant's going to focus on 2 main themes. One is quantum chemistry, another is aerospace engineering.
That's great. So as you can see that Kanav and his team don't just sit around waiting for users to sign up. They go out there and make some opportunities happen. This is really impressive stuff. So I urge everyone to go to qBraid.com, link in the show notes, and open an account and see what it's like to play in that environment. And if you're part of a bigger company with a team, as Kanav said, there's ways to make it something that's actually useful internally. So it's definitely worth checking out. So thanks again, sir. I'll see you in one of our very many meetings after this.
I believe there's a meeting tomorrow as well.
Yeah, absolutely. See you there.
Thank you so much for the invite, Konstantinos. It's a pleasure being here.
Now it's time for Coherence, the Quantum Executive Summary, where I take a moment to highlight some of the business impacts we discussed today, in case things got too nerdy at times. Let's recap. qBraid lets you access quantum computing software and hardware from most major providers, all in one interface. Similar to when using other coding notebook models, you just load an environment and start typing or modifying code. No worrying about installing dependencies and the like. The site now features qBraid credits you can buy too, so you don't have to worry about having API keys to access real quantum hardware on the back end. While the site began as a place for anyone to learn and experiment, it's now evolved to also support more enterprise-level use. You can buy credits in bulk for your team, and then divvy them up by role, project, and so on. You can even impose limits on jobs to prevent accidentally running up a huge bill on multiple shots, for example. There is segmentation in place for these types of corporate users, and qBraid even supports installing in private clouds, if needed, to meet some kind of requirements. Corporate users enjoy bundled hours of technical support, too. qBraid is also supporting the world of academia now via qSteam. The platform will be available to 300 institutions over the next 5 years, allowing professors to create complex course curriculums by adding modules. These modules can be mixtures of text explanations and executable code windows, which should be familiar to anyone who's used JupyterLab or Google Colab tutorials, for instance. The team at qBraid is still involved in research, too, recently winning a grant for a use case featuring the simulation of proteins by chopping the problem into sizes manageable for today's quantum systems. If you'd like to try qBraid, either on your own or through a corporate account, check out the link in the show notes. That does it for this episode. Thanks to Kanav Setia for joining to discuss qBraid. And thank you for listening. If you enjoyed the show, please subscribe to Protiviti's The Post-Quantum World and maybe leave a review to help others find us. Be sure to follow me on all socials at Constant Hacker. That's Constant with a K, Hacker. You'll find links there to what we're doing in quantum computing services at Protiviti. You can also DM me questions or suggestions for what you'd like to hear on the show. For more information on our quantum services, check out Protiviti.com or follow Protiviti Tech on Twitter and LinkedIn. Until next time, be kind and stay quantum curious.